Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the 12th part of this series of CSIR NET physics June 20 June November 2020 paper solution. Okay, so and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so let's get started. Okay, so first question of the day. These are part C questions I'm solving guys. Okay, part C questions of June November 2020 paper. Okay, CSIR net physics paper. Okay, so first question of the day, that is question number 1. Okay, question number 1 is this is different. This is okay, we are solving differential equation. Okay, so question from differential equation. So question is the solution of the differential equation the solution of the differential equation that is given, that is dy over dx whole square. This is 5 marks question guys. Okay, part C question. So dy by dx whole square minus d2y over dx equal to e to the power y. Okay, so this is the differential equation with the boundary condition with the boundary condition boundary conditions y0 y at x equal to 0 and y dash 0 y dash at x equal to 0 equal to minus 1. Okay, is, so these are the boundary condition given. Okay, and options are given guys. Option number A is minus ln x square by 2 plus x plus 1. Okay, and option B is minus x ln e plus x. Okay, and option C is minus x e to the power minus x square. Okay, and option D is minus x into x plus 1 e to the power minus x. Okay, so this is the question guys, simple question. Okay, the solution of the differential equation dy over dx whole square minus d2y over dx equal to e to the power y with boundary conditions y0 equal to 0 and y dash 0 equal to minus 1 is. Okay, so I'm going to start I'm going to solve this question. Okay, so little bit tricky question guys, but easy question. Okay, okay, so I'm going to start. The question is, okay, okay, so we have been given, first we will write the differential equation which is given. Okay, so this is dy over dx whole square minus d2y over dx square equal to e to the power y. Okay, so this is not like it is not in the form like it is a second order differential equation, but it is not in the form of linear second 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 order linear differential equation, right? So here we are going to do some substitution. Okay, so this is the equation. So what we are going to do is let e to the power y equal to p, let's say. Okay, so it means that implies y is going to be equal to ln p. That substitution we are going to do in this equation, okay, for solving it. Okay, so now we'll put the value. Okay, so this is going to be okay. So this is the one, right? So now what we can do is we can find dy over dx. Okay, dy over dx is going to be differentiation of this, okay, with respect to x. So this is 1 upon p, simple differentiation guys, 1 upon p dp upon dx. Okay, now what we are going to do, now we'll find d2, this we can say this is equation number 1. Okay, so d2y upon dx square is going to be, again we'll differentiate it, right? So this is going to be so here you need to understand guys, so this means d upon dx into 1 upon p dp upon dx, right? You have two functions, 1 upon p and dp upon dx, right? So we'll use product rule in differential equation, right? So this is going to be, this implies d2y over dx square is going to be first function, differentiation of second, right? So this is 1 upon p d2p upon dx square, right? And then it is going to be this one minus, so now we'll differentiate this 1 upon p, right? So differentiation of 1 upon p is minus 1 upon p square, simple differentiation, and then dp upon dx, and dp upon dx is also there, right? So this is dp upon dx whole square. Okay, so this is the value of d2y over dx square, simple differentiation guys. Now what we are going to do is we are going to put the value of dy over dx and d2y over dx in equation 1. Okay, so putting the value, okay, putting the values in 1. Okay, so now we'll put the value. Okay, so this value is going to be dy over dx value is 1 upon p dp upon dx, right? So this is going to be, and its whole square, right? So 1 upon p square dp upon dx whole square is going to be, so 1 upon p square dp upon dx whole square, dp upon dx whole square, dp upon dx whole square minus the value of this one guys, d2y over dx square, this value, right? 1 upon p d2p upon dx square, right? And minus 1 upon p square, minus going to be plus, right? Plus 1 upon p square dp upon dx whole square. Okay, that is going to be equal to p, because here we have done substitution, right? E to the power y equal to p, right? So now what we can do is, so now it is okay. So now these two will get added, right? Same thing. So it is going to be 2 upon p square dp upon dx whole square minus 1 upon p dp upon dx square equal to p. We can take this side, okay? So this is p will take this side, okay? So this is going to be 2 by p square p cube, okay? 2 by p cube dp upon dx whole square minus 1 upon p square d2p upon dx square equal to 1, okay? This one. So now we'll write in this form. We can write this like next page I'm going to write. So this is going to, we can multiply by minus, okay? So this is going to be 1 upon p square d2p upon dx square one upon p square d2p upon dx square d square minus okay, so this is going to be 1 upon p square d2p upon dx square minus 2 upon p cube dp upon dx whole square, okay? This is going to be equal to minus 1, okay? Simple thing, we have multiplied by minus 1, okay? So minus 1, so this is going to be this one, okay? This will be plus, this minus, and this side will be minus, right? Simple. So now we can write, this is the differentiation of, guys, this one, d upon dx into 1 upon p square dp upon dx, okay? So this is the differentiation of this type, okay? This we need to understand, very important step, this one, okay? This one, how, if you differentiate this, this is giving this value, okay? So this is going to be, if we differentiate this, to 1 upon p square d2p upon dx square, and then differentiation of this minus, okay? So this is going to be minus 2 upon p cube and dp upon dx whole square, right? So this is the differentiation of these two functions, okay? D upon dx, 1 upon p square, dp upon dx. So very important step, and that is going to be equal to 1. Okay, now we'll solve it. So let's say, let 1 upon p square dp upon dx is z, okay? So this means this equation is going to be dz upon, this equation is going to be dz upon dx equal to minus 1, right? Because we have put this value as z. Now we'll solve it. So this is going to be, this implies dz is going to be minus dx, will integrate it, okay, and plus any constant. So this is going to be, z is going to be equal to minus x plus c, right? Minus x plus c. Next, now what we are going to do is, now we'll put the value of z, okay? Z is this 1 upon, what we have supposed to consider, 1 upon p square d upon dp upon dx, 1 upon p square dp upon dx, okay? So this is going to be 1 upon p square dp upon dx is going to be minus x plus c, right? Again, what we can do is we can do dp upon p square is going to be minus x plus c dx, right? Integration plus one constant d. So this is going to be, if we solve this, this is going to be differentiation, right? This is going to be minus 1 upon p, right? Differentiation of integration of dp upon p square, or integration of 1 upon p square dp. Okay, so and this is going to be minus x square by 2, right? And this is plus cx plus d. Okay, well, now we'll find the value of p. So from here, value of p is going to be 1 upon x square by 2 minus cx minus d. Okay, minus cx minus d. How? We have taken minus common. Okay, minus will get cancelled, so this is going to be plus, this is minus cx and d, right? This is the value of p. Now value of p we have, we know, right? We have, suppose that we have considered p equal to that e to the power y equal to p, right? That we have substituted initially. So this is going to be e to the power y equal to 1 upon x square by 2 minus cx minus d. Okay, this is the one, guys, this one. next what we can do is we can for, so value of y is going to be ln 1 upon this value, right? X square by 2, 1 upon x square by 2 minus cx minus d, minus cx minus d, okay, this is the value. So now, or we can write y equal to ln 1 minus ln log a by b, right? Minus x square by 2 minus cx minus d. And y is going to be, the log value of 1 is 0, right? Log 1 is 0, so this is going to be minus ln x square by 2 minus cx minus d. Okay, this one, cx minus d. Now we'll put the boundary condition for getting values of constant a, b, c and d. Okay, so now first condition we have been given, since y0, first boundary condition, y0 equal to 0 means x equal to 0 and y equal to 0. So this means 0 is going to be minus ln x square is 0, right? X is 0, so implies x equal to 0 and y equal to 0. We are putting values of 0 minus 0 minus d, right? So this is going to be this 0, we can write log ln 0 is, ln 1 is 0, right? Value of ln, since ln 1 value is 0, so in place of 0 we can write ln 1. Okay, so this is going to be ln 1 is going to be equal to ln minus d to the power minus 1, we can say, because by log property. Okay, this will go to the power. So now ln will remove that. So this is going to be, will get cancelled. So I is going to be minus d to the power minus 1, right? This implies minus 1 upon d equal to 1. That implies value of d equal to minus 1, right? So we'll put this value. So then the y is going to be minus ln x square by 2 minus cx. D value is minus minus plus 1. Okay. Now we'll use second boundary condition, y dash, right? First we'll differentiate this with respect to x. So this is going to be dy over dx, or we can write y dash. Y dash is going to be equal to this one. We'll differentiate with respect to x, right? So this is going to be 1 upon x square by 2 minus cx plus 1. Okay, this is the value, and because the differentiation of 1 upon log x equal ln x equal to 1 upon x. Okay, and then differentiation of this is going to be x minus c. Okay, right. Now we'll put the boundary condition, second boundary condition. We have been given second boundary condition, that is, since we have been given that, right? So we have been given y dash at 0 equal to 0. This means y dash equal to 0 and x equal to 0, right? We'll put this here, right? So this is going to be y dash is 0 equal to 1 upon an x. Okay, here the boundary condition is not this. Boundary condition is, let me check. Boundary condition is y dash 0 equal to minus 1, guys. Okay, so this is 0 equal to minus 1, and this is minus 1. Okay, so this is going to be, now we'll put the value. So this is minus 1 is going to be, we'll put it in value of y dash of an x. Okay, so this is going to be y dash upon 1 upon equal to 1 upon, this value is going to be 0, right? X square by 2 means 0, and x is 0, right? Minus 0 plus 1 into x minus 1. X is 0, 0 minus c, right? So this from here, minus 1 is going to be equal to minus c, right? Minus c. So that implies value of c is 1. Value of c is 1. Okay. Any mistake we have done? Yes, we have done mistake. So that is minus ln, guys. This is minus. Right. So minus means minus minus plus and minus. So value of c is minus 1, guys. Okay. So now we'll put value of c and d, right, in this equation. Okay. So in this equation, suppose this equation is 2. Okay. In this equation we'll put, so y is going to be, implies y is going to be minus ln x square by 2 minus cx. C value is minus 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 plus, right? Plus x, c is 1, right? Minus 1 minus minus plus x, and d is also 1, right? So plus 1. This is not equation 2. In this equation, okay, this is equation 2, we can say. So this is going to be plus 1. Okay, so this is the answer, guys. So which option is matching, guys? Y equal to minus ln x square by 2 plus x plus 1. So which option is matching? Let me check the option. So option A is correct, guys. Option A is matching, right? So this is the correct answer. Well, guys, so next question we are going to solve. Next question is a lengthy question, guys. Okay. This is also a good question, guys. This question is from atomic and molecular physics. I'm going to solve that question. It's a lengthy question actually. Next question is, if we take the nuclear spin, the nuclear spin. This question is from atomic and molecular physics. So if we take the nuclear spin I into account, okay, into account, okay, if we take the nuclear spin I into account, okay, so we are considering the nuclear spin also, right? That's what it is saying. Account the total angular momentum, the total angular momentum, the total angular momentum is F equal to vector L, vector S, vector L plus vector S plus I. Okay, this is the F value. Okay, this is we know this is the orbital angular momentum, this is spin angular momentum, and this is nuclear angular momentum. Okay, so this one we have studied in atomic physics. This. Okay, so I where L and S are the orbital and spin angular momenta, spin angular momenta of the electron, the Hamiltonian of the hydrogen atom is corrected by the additional interaction lambda I dot L plus S. Okay, so that Hamiltonian is corrected by additional interaction. Okay, this is the Hamiltonian which is given, where lambda greater than 0 is a constant, the total angular momentum, the total angular momentum, the total angular momentum, quantum number, total angular momentum quantum number F of the p orbital, of the f of the p orbital, total angular momentum, quantum number, f of the p orbital state, p orbital state with lowest energy. Okay, p orbital state with lowest energy, whose energy is lowest. Okay, with lowest energy is, options are option A 0, option B equal to 1, option C 1 by 2, option D 3 by 2. Okay, so this is the question, guys. Okay, so I'll read it for you. Question is, if we take the nuclear spin I, okay, if we take the nuclear spin I into account, means if we consider the nuclear spin also, the total angular momentum is F equal to L plus S plus I. Okay, the sum of orbital angular momentum, spin angular momentum, and nuclear spin momentum. Okay, where L and S are the orbital and spin angular momenta of the electron. Okay, the Hamiltonian of the hydrogen atom is corrected by additional interaction. Okay, that is lambda I dot L plus S. Okay, where lambda is greater than 0 and is a constant. The total angular momentum, total angular momentum quantum number. Okay, total angular momentum quantum number F of the p orbital state with lowest energies. Okay, that's what we need to find. Okay, the total angular momentum F, the value of F, total angular momentum value of total angular momentum quantum number of right, that is F of the p orbital state with lowest energy, we need to find out. Very good question, guys. Well, so I'll start now. Okay, so we have been given, right, we have been given in question, this is F is given, right, total angular momentum, F is given L plus S plus, okay, L plus S plus I, or we can write this J plus I, because we know F equal the J equal to L plus S, right, this we know, this is angular momentum. Okay, so we can write J plus I. Okay, J plus I. Now we have been given Hamiltonian. Okay, the corrected Hamiltonian that is given, that is lambda I dot L plus L, L plus L. Okay, so we can write this lambda I dot J, because L plus L is J, right, or so this is going to be H value. So H value is lambda I dot J. Okay, this is the value of H Hamiltonian. Now here we know, since we know F equal to J plus I, that we know, right, or we can write F square. F square is going to be mod of F square is going to be mod of J square plus we are so we have multiplied F. Okay, so this is the mod square, taken mod square. Okay, so this is mod I square plus 2 J dot I, right, this is the one. So from here J dot I is going to be F square, directly we can write, okay, f square minus j square minus I square. Okay, these are mod values upon 2, right? This is we know, right? This is what. So now what we can do is, these are the value of j dot I1. We can put this value in this equation. So h is going to be lambda, and this is going to be f square minus j square. These are mod square of f and j, right? F square minus j square minus I square upon 2. Okay, so this is the one. Okay, so h equal to lambda f square minus j square minus I square upon 2. Okay, this one. Now for hydrogen atom, so it is asking for this question. The question we need to read carefully, right? This is the Hamiltonian given. Okay, okay, correct it. So here this is given, right? The total angular momentum number we need to find out. Total angular momentum f of the p orbital state with lowest energy, p orbital state. Okay, p orbital state means for hydrogen atom, this we can say equation number 1. Okay, for hydrogen atom, okay, for hydrogen atom, so we have it also in question. It is asked for the quantum number f of the p orbital state, right? P orbital state of the p orbital state, right? So for hydrogen atom, p orbital electron. Okay, p orbital electron, p orbital. For hydrogen atom, p orbital electron. Okay, p orbital electron. For p orbital electron, L is going to be 1 for p, right? And S is going to be half, right? So this implies for p orbital, for what p orbital electron we are talking about. If we talk about p orbital electron, then L is 1 for p orbital electron and S is half. That is this spin. So this implies value of J is going to be, that we know, right? That is 1 by 2 comma 3 by 2, because value of J equal to mod, this we know, okay, mod L plus S to mod L minus S. Right? So this is the value of J. Now we will find an I value. You need to note down. I value is 1 by 2, guys, for spin. Nuclear spin is I is 1 by 2 for nucleon. Okay, this is I is 1 by 2. Okay, you need to note down this. I equal to 1 by 2. So for I, this one, this implies for I, value of J is going to be, I is 1 by 2 and J is 1 by 2. That implies value of F is going to be, F value we know right here, right? Value F is this one. F value is J plus I, right? So F is going to be J plus I, means this one. Zero comma 1, right? 0 comma 1, J plus I, right? This is I. So I is this, so F value is going to be J plus I, right? Because the f value is going to be like mod of f plus I to mod of f minus, right? Mod of f minus I. Okay. So this is the value for f. Now for I equal to 1 by 2 and I is 1 by 2 and value of j, because we have two values of j, right? The second value is 3 by 2. In that case, f is going to be, f value is mod of f plus I to mod of f minus I, right? So this value is going to be this one, 1 2, right? 1 comma 2, 1 comma 2. Okay. Well, these are the values of f and ijf and ijf. Okay. So now we are going to find that Hamiltonian, that is delta E1. Okay, this is Hamiltonian, or we can write delta E1 as well. Delta E also we can write. Okay, so this delta E1 will find out. Delta E1 is going to be, delta E1 is going to be this formula we know, right? Lambda, right? Lambda f square minus j square minus I square, this one, I square by 2. Okay, so delta E1 is going to be, E1 means this value, I equal to 1 by 2, j equal to 1 by 2. Okay, and f equal to 0, delta E1. Okay, so we'll find delta E1. Delta E1, it is f equal to 0, I equal to 1 by 2, and j equal to 1 by 2. Right, for these values, this one, I equal to 1 by 2, j equal to 1 by 2, and f equal to 0. Okay, so for this delta I will put the value. Okay, so and now this value we know, right? These are mod of f square, j square, and this, and here we know, guys, I'm going to write it, f is value of f is h cut root f into f plus 1, right? This we know, and so this means f square value is going to be f square value is going to be h cut square into f plus 1. Okay, f is quantum number, total quantum number. Similarly, j is going to be j square equal to h cut square j into j plus 1, and for I, it is going to be I square is h cut square I into I plus 1, right? So we'll put the value here. This is going to be delta E1. This value is going to be, delta E1 value is going to be lambda into lambda h cut square, we can take common. Okay, this is going to be h cut square lambda, or I'll write first. Okay, so this will be better. This is going to be lambda h cut square f into f plus 1 minus h cut square j into j plus 1 minus h cut square I into I plus 1 upon 2, right? So these are the value, we'll put it. So delta E1 will put the value. Okay, so f is 0, lambda h cut square will take common, so f is 0, minus h common j into j plus 1, 1 by 2 into 1 by 2 plus 1, 3 by 4 minus 3 by 4 upon 2, right? So this value is going to be minus 3 by 4 lambda h cut square. Okay, minus 3 by 4 lambda h cut square. Okay, so this is the delta 1, delta E1. Now we'll find delta E2. Delta E2 means this value. 1 by 1 we need to find, and these values are for p orbital. Okay, f equal to, here you can see this one. Now for the E1 we have taken I half, j half and f0, right? Now E2 I half, j half and f1, right? So f equal to 1, I equal to half, j equal to 1 by 2, 1 by 2, right? Again, this value is going to be lambda h cut square. Now I'm putting value directly. So this is going to be f value is 1, right? So 1 into 1 plus 1 f, right? Minus j. J value is 1 by 2 and 3 by 2 and minus 3 by 2, right? Upon 2. So delta E2 is going to be, if you calculate it, it is a simple calculation, you can do it. So delta E2 value is going to be minus 1 by 4 lambda h cut square. Now we'll find delta E3. Delta E3 means here. Delta E3 means I equal to 1 by 2, j equal to 3 by 2, f equal to 1. Okay. So this is going to be delta 3 E3, I equal to 1 by 2, j equal to 3 by 2 and f equal to 1. So this value is going to be again lambda h cut square, j into j plus 1, f is 1 into 1 plus 1 minus 1 by 2 j into j plus 1 means 3 by 2 into 3 by 2 plus 1 minus I into I plus 1, I 1 by 2 into 1 by 2 plus 1 upon 2. We solve it, simple calculation. So this is going to give minus 5 by 4 lambda h cut square, right? Now we'll find delta 3, delta E4. Delta E4 means this one. I equal to half, j equal to 3 by 2 and f equal to 2, right? So this is E4, right? Delta E4. E4 is going to be I equal to half, j equal to 3 by 2, f equal to 2, right? So this value is going to be delta E4. This is going to be this value. Lambda h cut square, this 2 into 2 plus 1, f value is this, right? Minus 3 by 2 into 3 by 2 plus 1 and minus half into half plus 1 upon 2. Okay. So now we solve it. So this is going to be, this value is going to be delta E4 is going to be, if you solve it, 3 by 4 lambda h cut square, right? So we have for p orbital state we have 4 energy levels. Okay, 4 delta E1, okay, delta E2 and delta E3 and delta E4. Okay, now we'll compare the energies because we need to find out in question the lowest energy, right? The total angular momentum F we need to find out. The total angular momentum quantum number we need to find F of the p orbital state with lowest energy. Okay, so if you compare the energy, E4 is plus, right? So it's highest energy. Okay, and E1 is also in positive, right? So these are highest energy, so we'll not take those energies. Now E1 is this one, right? No, E1 is minus 3 by 4, E2 is 1 by 4. So E2 and E4 will not take. Now we'll compare this one. E3 is minus 5 by 4 and E2 is minus 3 by 4. So in minus 3 by 4 and in minus 5 by 4, minus 5 by 4 is the lowest value because that value is greater, and in minus greater value is lowest, right? So E3. So for E3, this is 5 by 4. You can see the value of F is 1. Value of this F is quantum number, right? Total angular quantum number. For this, you can see value of F is 1. So 1 will be the answer, guys. Which option is matching? This option B is matching, guys. Option B is the correct option. Option B is the correct option. Okay, this is how we solve this question, guys. So it's a vector model question of atomic molecular physics. So I would suggest you practice this, guys, because it's an easy question but lengthy one. So I would suggest you practice it, right? Because these questions are part C question, and you can see that it is taking half an hour to solve one question. Okay, so you need practice, guys, for these questions. Now next question we are going to do question number 3rd. Okay, question number 3rd. Question number 3rd. This is also question from atomic and molecular physics. Okay, molecular physics actually. Okay, so question is easy question, formula based question. The absorption lines, the absorption lines the absorption lines, the absorption, the absorb, the absorption lines, the absorption lines arising from, the absorption lines arising from okay, the absorption lines arising from pure rotational, pure rotational, pure rotational effects of, pure rotational effects of, pure rotational effects of SCl, pure rotational effects of SCl are observed. Okay, are observed, are observed at 83.03 centimeter inverse, comma 103.73 103.73 centimeter inverse, centimeter inverse, then 124.30 centimeter inverse, comma 145.03 centimeter inverse, and 165.51 centimeter inverse, okay. The moment of inertia, the moment of inertia the moment of inertia of the HCl molecule is, okay, take h cut upon 2 pi c value equal to 5.6 into 10 to the power minus 44 kg meter, okay, kg meter. Options are 1.1 into 10 to the power minus 48. Option B is 2.8 into 10 to the power minus 47. Option C is 2.8 into 10 to the power minus 48. And option D is 1.1 into 10 to the power minus 42. minus 42. These are kg meter square, okay. Kg meter square. Okay, so this is the question, guys. Simple question, formula based question, okay. I'll read the question for you. The absorption lines arising from pure rotational effects of HCl, okay. See, the absorption lines, guys, arising from pure rotational effect of HCl means pure rotation of HCl, okay, okay, are observed at 83.03 centimeter inverse, 103.73 centimeter inverse, 124.30 centimeter inverse, 145.03 centimeter inverse, and 165.5 centimeter inverse, okay. 51 centimeter, okay, inverse. The moment of inertia of HCl molecule we need to find out. It's just formula based question, okay. So it's a pure rotational spectrum of HCl atom. It is, okay, pure rotational spectrum of HCl atom, absorption spectrum, okay. So and so these are the lines given. So now we need to find out that the moment of inertia of HCl atom, okay. So very simple, guys. So in pure rotational spectrum we know the spacing of energy, right? The spacing is 2b, guys, like this rotational spectrum, right? The spacing is equal energy spacing, and that is equal to 2b, okay, in the rotational spectrum. That's what you need to know. Now now we'll find 2b. 2b means 2b means these are right, 103.73 minus 83.03, and then 2b is also this 124 minus 30 minus this minus this minus this, okay. So we'll get those 2b values, okay, and then we'll get the average of 2b, and then we'll find the b value, okay. So 2b is going to be, 2b is first, these are the energy gap, right? So that is 103.73 minus 83.03, okay. So you can calculate it. This value is 20.70 centimeter inverse, okay. So this one 103 minus this, now 124.30 minus 103, right? So 2b, that is the spacing, okay. 2b is going to be this constant, 124.30 124.30 minus 103.73, 103.73, and this value is going to be 20.57 centimeter inverse. Okay, next 2V is going to be 145.03 minus 124.30, and that value is 20.73 centimeter inverse. Next is 2V. Okay, so this one, so 1, 2, 3, something missing. Let me check. Okay, 103.73 and then 124. Okay, okay, so this is the one. Now we'll find the average value. Okay, these are the rotational values, right? We've got, and this is also we can. So now we'll find the average. So average value, that is average value of 2V is going to be so we are going to take the average of this. Okay, so this is going to be B 2V. 2V is going to be 20.70 plus 20.57 plus 20.73 divided by 3. Okay, divided by 3, and this value is going to be 10.33 centimeter inverse. Okay, and now this is the average, and now this is in centimeter. We'll convert it into meter. So this is going to be 1033 meter inverse. Okay, meter inverse, meter inverse. Okay, so now this is the so from here value of B. So this is the one, guys. This is upon 3. Okay, so this value is this actually. Write it. This value is 20.67, right? So 2B is this, right? So B value is going to be 20.67 centimeter inverse by 2, and so this value is going to be this one, 10.33 centimeter inverse, and that is 1033 meter inverse. Okay, so this is the value of B. Now we have just as a formula based question. It is just we need to first find the value, the average value of B. Okay, and then this is going to be I. That I is moment of inertia of SCL. Okay, this one, moment of inertia, moment of inertia of SCL, right? Moment of inertia of SCL is going to be I equal to this formula. You need to note down, guys. Okay, h cut upon 4 pi BC. Okay, this is very important one. Okay, h cut upon 4 pi bc. Okay, bc where h cut equal to this, we know, right? H cut equal to h upon 2 pi, h upon 2 pi. Okay, so this is h cut upon 4 pi bc, simple. So this is going to be h cut upon 2 pi c into 2 into b, we can write, right? And b value given, right? H cut upon 2 pi c into 2, and value of b is this one we have found, right? At average value 1033, 1033, and this value h cut upon 2 pi c, right? H cut upon 2 pi c, h cut upon 2 pi c, this value is given in question, right? H cut upon 2 pi c value is given here, this one. H cut upon 2 pi value is given 5.6 into 10 to the power minus 24, right? So we'll write this value. So this is going to be 5.6 into 10 to the power minus 44 upon 2 into 1033. We'll solve it, and this value is going to be 2.7 into 10 to the power minus 47 kg meter square, right? Kg meter square. This is the momentum. Okay, so this is formula based, guys. Just you need to find there are different lines, absorption lines are given, okay, for pure rotational. Okay, and what we have done is we have just got the average value of 2b, right? Okay, for rotational spectrum 2b value, and then we have a formula that I equal to h cut upon 4 pi bc. Okay, so we have put the value of p, and h cut upon 2 pi value is given. We have calculated and got the answer, right? 2.7 into 10 to the power minus 47. Which option is matching? Option, okay, minus 47. This one, option B is matching, guys. Option B. Option B is matching. Okay. Next question, guys. Okay, next question. Question number 4. These are this is also good question. This is also from atomic and molecular physics, from laser, right? This question is from laser. Okay. Question number 4. Question number 4 is the energies of the energies of the energies of the three lowest states of an atom of an atom are E0 equal to minus 14 electron volt, E1 equal to minus 9 electron volt, and E2 equal to minus 7 electron volt. Okay, these are the energies of different levels, E0, E1 and E2. Okay, the Einstein coefficients are the Einstein coefficients are Einstein coefficients are Coefficients are A10, which is given, that is 3 into 10 to the power 8 second inverse. Okay, 8 second inverse. And A20 is given, that is 3 into 10 to the power 8 second inverse. Okay, this is 3. Okay, this is A20 is given, and okay, this is wrong, guys, my apology. So this is 1.2 into 10 to the power 1.2 into 10 to the power 8 second inverse, and A21 is given, that is 8 into 10 to the power 7 second inverse. Okay, if a large number of atoms, if a large number of atoms are in the energy level E2, are in the energy level E2, the mean radiative lifetime of this excited state, lifetime of this excited state is options are, option A is 8.3 into 10 to the power minus 9 second. Option B is 1.1 into 10 to the power minus 8 second. Option C is 0.5 into 10 to the power minus 8, and option D is 1.2 into 10 to the power minus 8 second. Okay, so these are the options, guys. It's a good question and very simple question, formula based question, guys. Okay, okay, so I'll read the question. So the energies of the 3 lowest states of an atom, okay, so 3 lowest states of an atom's energy is given, okay, are E0 minus 14 electron volt, E1 minus 9 electron volt, and E2 minus 7 electron volt. Okay, the Einstein coefficients are A10 is given 3 into 10 to the power 8 second inverse. A20 is given, that is 1.2 into 10 to the power 8 second inverse. A21 is given, that is 8 into 10 to the power 7 second inverse, right? if the large number of atoms are in the energy level E2. Okay, so the large numbers of atoms are in the energy level E2. Okay, the mean radiative lifetime of this excited state is. So we need to find the mean radiative lifetime of this excited state, means mean radiative lifetime of this uh, E2 state. Okay, that we need to find out. Very simple question. So I'm going to solve it. So there is a formula, right? So the rate of spontaneous decay from E2 state, okay, that is a formula. Okay, so the rate of, you need to note down, the rate of spontaneous, the rate of spontaneous, rate of spontaneous decay, rate of spontaneous decay, spontaneous decay from E2 state, from E2 state, rate of spontaneous decay from E2 state. Okay, that is guys A21 A20 plus A21 into N1, that is number of atoms, okay, equal to A2 N1. Okay, so this is the important formula you need to note down. Okay, so this is rate of spontaneous decay from E2 state. Okay, so this rate of spontaneous decay from E2 state is A20 plus A21, okay, N1 equal to A2 N1. Okay, A20 plus A21 N1 to A2 N1, right? So N1 N1 is going to be cancelled. Okay, so value of A2 is going to be A20 plus A21. Okay, so this value is going to be, we can put the value. A20 value is, we have, that is 1.8 into 10 to the power 8 second, plus value of A21 is given, A21 is this one, A21 is given 8.8 into 10 to the power 7, right? Or because we can write it like this, 8 into 10 to the power 7, okay, per second, right? So now we'll add it. So this is going to 1.8 into 10 to the power 8 plus so we can write this 0.8 into 10 to the power 8 for adding, right? So this is going to be 2 into 10 to the power 8. Okay, 2 into 10 to the power 8 is the value of A2, guys. Okay, so this is the rate of spontaneous decay from E2 state. Okay, so that is A20 plus A21 N1 equal to A2 N1, and A2 value we have got it now. There's a formula, a mean radiative lifetime. So therefore mean radiative lifetime, mean radiative lifetime is, that is tau 2, because we have to find the radiative lifetime for E2 state, right? So that's why I'm writing tau 2. Tau 2 is simple 1 upon A2. Okay, so this is going to be 1 upon 2.0 into 10 to the power 8, right? So this value is going to be 0.5 into 10 to the power 8 second inverse. Okay, so which option, this is, sorry, second inverse, no, this is second, this one open, right? This is second. Okay, so this is the mean radiative lifetime. So which option is matching? Option C is matching, guys. Okay, option C. Okay, guys, so okay, yeah, Disney Junior, yes, Disney, I will complete the syllabus, and also I would like to tell you that I have completed quantum mechanics. So you can check my playlist. Okay, I have completed quantum mechanics. That is complete detailed course. Okay, uh, and also I have completed mathematical physics. That is of 35 lecture. Quantum mechanics of 29 lectures. Okay, those two subjects are completed. Optics is completed. Detailed course of optics is completed uh, in uh, in uh, in 7 lectures. And yesterday I have completed particle physics also. That is complete detailed course of particle physics in 2 lectures of 3 hours. That was around 3 hour lecture. Okay, so many courses have been completed. So as of now, uh, that is thermodynamics and statistical physics, electronics, and one more, that is this one. Yes, condensed matter physics, which are going on, and I'm sure these three are also going to be completed in this month. Okay, and then we'll start quantum mechanics and no, that is classical mechanics and electrodynamics. Okay, and next Sunday, in next 2 Sundays, I'm going to complete nuclear physics, and next 2 or 3 Sundays I'm going to complete the digital electronics, guys. Okay, so Disney Junior, yes, I'm going to complete all 9 subjects. So I would suggest you can watch my lectures, uh, which are available in playlist. Okay, so everything is explained in detail, so you can check. And also I'm solving PYQs as well. Okay, so I have solved complete that 2019 June paper and 2019 December paper, which I have completed in 11 and 10 lectures respectively. And this 2022 paper is also going to be completed in next lecture or next to next lecture. Okay, so it will get complete in 14 lectures, 12 to 13 lectures. So yes, Disney Junior, I'm going to complete all 9 subjects. Okay, so next class is of condensed matter physics. Okay, so remaining portion we are going to do in the next class. Okay, for this. Okay, guys. So, and also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, and also I would request you to share this uh, with your friends as well who are in MSc. Okay, who are preparing for the NET examination and an examination related to physical science, so that they can also take the benefit and can also learn. Okay, okay, guys. Thank you so much. Bye now. So next, after this class, I'm taking next class, and that class is going to be of condensed matter physics. Okay. Thank you, guys. Bye now.